Right now, underneath your feet, there's a liquid worth more than gold. Ancient, black and powerful. But here's what nobody tells you. The oil that comes out of the ground is completely useless. You can't put it in your car. So how does this prehistoric sludge become the fuel that powers our entire civilization? Stick around, because what you're about to see will change everything. Our story begins 300 million years ago, not in a laboratory, not in a factory, but at the bottom of ancient oceans. Tiny organisms, plankton, algae, and prehistoric plants lived, died, and sank to the ocean floor, layer upon layer, year after year, century after century. Then something incredible happened. As these layers got buried deeper and deeper, sometimes miles below the surface, the pressure became immense. The temperature skyrocketed to over 300 degrees Fahrenheit, and in this underground pressure cooker, organic matter began to transform. Fast forward to today, we drill down through miles of rock to tap into these ancient reservoirs. And when that drill bit finally breaks through, what comes up is, well, it's disgusting, thick, black, sticky crude oil. This stuff on the left, crude oil straight from the ground. This stuff on the right, premium gasoline. They're made from the same thing, but they couldn't be more different. So what happens in between? Let's find out. Welcome to an oil refinery. This is where the magic happens. These facilities are some of the most complex industrial plants ever built. A single refinery can span thousands of acres and cost billions of dollars. And every single day, they transform millions of barrels of useless crude oil. The crude oil arrives by tanker ship, pipeline, or rail car, and before it can be processed, it needs to be cleaned. Remember, this isn't pure oil. It's contaminated with water, salt, and debris that could destroy the expensive equipment downstream. The first stop is the desalter. Here, the crude oil is mixed with water and subjected to powerful electric fields, up to 35,000 volts. The electricity causes tiny water droplets to merge together. Salt and other impurities dissolve in the water, which sinks to the bottom. The cleaned crude is then pumped into massive storage tanks. Some of these tanks can hold millions of gallons. But it doesn't stay there long, because the heart of the refinery is calling. This is a fractional distillation tower, and this is where crude oil gets torn apart molecule by molecule. These towers can be over 200 feet tall, and what happens inside is pure chemistry. Here's how it works. The crude oil enters a furnace where it's heated to over 750 degrees Fahrenheit. At this temperature, most of the oil vaporizes into a gas. This superheated vapor then shoots into the bottom of the distillation tower. Think of it like this. You know how when you boil water it turns into steam? Well, crude oil is actually a mixture of hundreds of different hydrocarbons, and each one boils at a different temperature. That's the secret we're about to exploit. The superheated vapor shoots into the bottom of the distillation tower. Now, inside this tower, there are dozens of perforated trays stacked on top of each other. And here's the brilliant part. The tower is hottest at the bottom and coolest at the top. As the vapor rises, it cools down. And as it cools, different components condense back into liquid at different heights. At the very top, where it's coolest, around 70 degrees Fahrenheit, the lightest molecules condense. These become petroleum gases and naphthas. A bit lower, around 300 degrees, we collect gasoline. Further down at 400 degrees, we get kerosene and jet fuel. Lower still, at 500 degrees, diesel fuel condenses. And at the bottom, the heaviest stuff that never vaporized, thick, heavy residual oil used for asphalt and industrial heating. One tower, one continuous process, multiple products. But here's the thing, we're only halfway through. Because what comes out of the distillation tower isn't ready for your car yet, not even close. If you want to see how we turn these raw fractions into premium fuel, hit that subscribe button right now. Trust me, the next part is mind-blowing. Here's a problem. The distillation tower gives us whatever proportions nature decided to put in that crude oil, but the world doesn't want equal amounts of everything. We need way more gasoline than heavy fuel oil. So how do you make more of what you need? You break the big molecules into smaller ones. This process is called cracking. Imagine a long chain of carbon atoms. The fuel oil molecules might have 40 or 50 carbon atoms linked together, but gasoline molecules only have 8 to 12. So we need to crack those long chains into shorter ones. The most common method is fluid catalytic cracking, or FCC. Heavy oil is sprayed into a chamber filled with extremely hot catalyst particles. Tiny beads of zeolite heated to over 900 degrees Fahrenheit. These particles act like molecular scissors, breaking those long chains apart in seconds. But catalytic cracking isn't the only game in town. Thermal cracking uses pure heat and pressure. No catalyst needed. Hydrocracking adds hydrogen atoms while breaking bonds, making cleaner products, and coking heats the heaviest residues until they leave behind solid carbon called petroleum coke. Different methods, same goal, break big into small, but we're still not done, because even after cracking, the molecules aren't quite right. Some gasoline molecules are straight chains, but your engine needs branch chains for better performance, so we use isomerization. And then there's alkylation. This process combines small light molecules that would otherwise be waste gas and merges them into larger, high-octane gasoline components. It's like molecular Legos. Snap the pieces together, create exactly what you need. Now we've got the right molecules in the right size, but there's still a problem, sulfur. Even after all this processing, the fuel still contains sulfur compounds, and when sulfur burns in an engine, it creates sulfur dioxide, a toxic pollutant. The solution: hydrotreating. The fuel is combined with hydrogen gas and passed over a catalyst at high temperature and pressure. The hydrogen reacts with the sulfur compounds, converting them into hydrogen sulfide gas, which can be captured and converted into pure sulfur. What's left behind, ultra-low sulfur fuel that burns clean. At this point, the fuel is almost ready, but not quite. It needs to be tested. Octane rating for gasoline, cetane number for diesel, flash point, pour point, vapor pressure. Every batch is analyzed to meet strict specifications. And then come the additives, detergents to keep engines clean, anti-knock compounds to boost octane, anti-icing agents for jet fuel, dyes to identify different grades. Each refiner has their own proprietary blend. The fuel your grandparents pumped in the 1950s, it was made in refineries that looked pretty similar to today's, but the fuel itself completely different. Modern gasoline is a precision-engineered chemical product that would blow their minds. The finished products are pumped into storage tanks. A large refinery might have dozens of these, each holding a specific grade of fuel. And from here, the distribution begins. Tanker trucks load up for local deliveries. Rail cars carry fuel across continents. Pipelines move millions of gallons per day. And specialized ships transport jet fuel to airports around the world. Every mode of transportation, all moving simultaneously. In a complex ballet of logistics, finally it arrives at your local gas station. That pump you barely think about. It's the end of a journey that began millions of years ago and traveled through some of the most complex industrial processes ever invented. You press a button, the engine roars to life, and all those carefully crafted molecules start burning at over 2,000 degrees Fahrenheit inside your engine, releasing the energy that was locked away when dinosaurs walked the earth. So the next time you fill up your tank, take a second to appreciate the journey. From ancient organisms to underground reservoirs, through furnaces hotter than lava and catalysts that work at the molecular level, past desalters, distillation towers, crackers, treaters and blenders, all to transform primordial sludge into the precise, powerful fuel that keeps our civilization moving. That single gallon of gas, it's not just fuel. It's millions of years of natural chemistry combined with human ingenuity at its finest. And that's how oil becomes fuel. Thanks for watching.